Hello everyone. Today we will present the result of our discussion with the theme we got, which is about E&T. Here we have written an article related to the existing theme, and of course we have summarized it. In addition, we also have other information material that we get from YouTube. Before I discuss further, I will introduce my group members. The first was myself, FADILA YUSUF is the moderator and the first speaker and also the last speaker. Then there was ABDUL GAPUR as the second speaker. Then there was AZMUL SIAUTA as the third speaker. Then there was NURMI as the fourth speaker. Then there was MURSALIM KELIWIDA as the fifth speaker. And the last one was RIQAH to NUFUS YUSUF. Okay, not to waste time, let's just go straight to the next discussion. Talking about energy and technology, of course we are talking about technologies related to field ranging from search, generation, storage, energy, conversion, and utilization as human needs. Well, in the article we read with the title, Not Just Another Break in the Wall, published by Stephen Cousins on Tuesday, January 18, 2022. In this article, they discuss the latest energy technology where for the first time in hundreds of years, walls can acquire new intrinsic functionality. In this article, they also discuss the four most promising technologies being developed in the lab. Okay, first there is a rechargeable concrete battery with its storage capacity or energy density is 7 Weber per square meter. Stages of development proof of concept, and the research location is in Sweden. This is a prototype cement-based rechargeable battery developed by researchers at Chalmers University of Technology, which has the capacity to power an ordinary E14 LED bulb for about an hour and a half, more than 10 times the capacity of previous concrete batteries. That may be a drop in the ocean compared to the energy potential of commercial batteries, but the enormous volume of concrete in the boiled environment can significantly increase storage. The power can be used either to generate the power itself or to feed it back to the power grid. The prototype exploits an innovative form of rechargeable electrode. It consists of a cement-based mixture containing short carbon fibers designed to increase conductivity and flexural softness and a metal-coated carbon fiber mesh. The mesh integrates an iron anode and a nickel cathode to create a flow of electrons and electric current.
Well, next is rechargeable bricks or supercapacitors with a storage capacity is 1 hour per square meter. Development stage proof of concept and the research location is in the USA. The supercapacitors bricks developed by research at the University of Washington in St. Louis introduced the idea that walls could become giant batteries capable of rapidly charging electric vehicles or other devices.
The patented technology utilizes the porous structure of tiny cavities-fired red bricks with nanofibers of plastic that can store the charge. In laboratory testing, several pieces of polymer-coated brick lit a 3-watt LED for 50 minutes. The energy density is currently only 1% of lithium-ion batteries. Although the researchers say this could be improved in the future either by increasing the energy density or using more bricks.
Okay, next is solar powered bricks. Power output approximately 117 to 175 Weber per square meter. The development stage is product development and research location in England. University of Exeter spin-off company Solar WAEL has developed a modular glass brick wound and embedded optical device that magnifies light to increase the amount that is converted into power. A prototype, while measuring 1 square meter, is capable of producing about 117 to 175 Weber per square meter of electricity in sunlight, not far from the average power output of a typical solar panel of around 200 to 225 Weber per square meter. Performance in the communal space drops to around 100 to 125 Weber per square meter.
Professor Tapas Malik, co-founder of SolarBuild, was sold to Solar Energy Research Group at the University of Exeter. Solar E&T with our technology of building can be completely self-sufficient, not only getting power from the roof but from the wall as well. It can be configured to feed energy into building grids or batteries for storage depending on power usage.
Next is the living brick. The power output is 1 milliwatt per 5 liters of wastewater or toilet water. The development site is a lab-scale prototype, and the location of the research in England will know that household waste and water waste are usually turned directly into the sewer, because if left unchecked it will cause bacteria. But this byproduct that contains a lot of bacteria can be used for energy. Scans at the University of the West of England in Bristol harness microbial volatiles to generate electricity and produce clean water. Each brick contains 2 compartments separated by a membrane. The microbeast is on site and use dirt water cycle. Its urine is a flood source. The chemical reaction produces electrons that flow into another compartment of clean water, in the process creating electricity. A prototype version of the system, running on urine at the Glastonbury Festival in 2019, delivered 3 watts of continuous power and a total of 300 watt-hours over 5 days. Efforts are now focused on harnessing the power of urine to bring electricity to remote hosts in sub-Saharan Africa. Professor Ioannis Larpous, director of the Bristol Biology Center at UI Bristol, told E&T, if the project is successful, the technology could be scaled up to serve the rest of the global population. He also said, if engineered properly, we can install microbial valve cages anywhere, in every household, public place, shopping mall, hospital, and hotel. If buildings become large-scale bacteria, they can store renewable energy from wind and solar during peak production times, then channel it back into the grid when it's needed most, or use it to charge electric cars.
Besides that, there is also a channel on YouTube whose name is Electric Future, where they also discuss about one of the latest energy technologies, namely Solar 3.0, and the video has been watched 7.4 million times. So, the solar cell is a power plant that is able to convert sunlight into electric current. The large amount of energy produced from sunlight makes solar cells a very promising alternative energy source in the future. Solar cells also have advantages, become a particle energy source considering that it doesn't require transmission because it can be installed modularly in any location where it is needed. Solar cells do not have excess noise like in wind power plants and can be installed in almost any area because almost every location in this part of the world receives sunlight. Until now, there are several types of solar cells that have been successfully developed by researchers to get solar cells devices that have high efficiency or to get solar cells devices that are cheap and easy to manufacture. The first type that was successfully developed was the wafer type or coated single crystal silicon. This type in its development is able to produce very high efficiency. And the second type of solar cell is the type of polycrystalline silicon wafer. Okay, so that's the presentation video from our group. Sorry if there are mistakes in pronunciation or delivery of material that is not quite right. Thank you for watching this video and don't forget to like, comment, and subscribe to this channel. Bye-bye. Wassalamualaikum warahmatullahi wabarakatuh.